Can you hear me now? Is this better? Yes. Was I on silent before? I talked for about 5 minutes. Great, right. Let me know if there's a problem with the sound. I have no idea why I was on silent then. Oh, great. Right. What did I talk about? Was I definitely on mute for all that time? Right. What did I talk about? I said that integration is the last main chunk that we're doing. There's two areas left of integration. There is this thing, which is by parts, which is what we're doing today, and there is integration by substitution, which we're going to start next week, which is by far the most difficult thing and you'll do all year, but it is probably the last thing you'll do all year, which is good. Okay, so the plan for this week, I talked over this a minute ago, but I showed you Mr. Stratford's notes, which you have to download. He will set an assignment. It'll be me teaching today and Thursday afternoon. Okay, so Thursday afternoon, 2 o'clock-ish, will be the lessons. You should all have a double lesson Friday, which you'll have to complete the assignment then. Okay, so, as I was saying to myself, integration by parts is a process. It's like another rule we have to learn, and it's the reverse of the product rule. So we would have done the product rule earlier this year with differentiation. That is when you have a product, two things multiplied by each other, which we tend to call U and V in this case. And if you multiply those things together and you want to differentiate something, which is two terms multiplied together, it is U dv by dx plus V du by dx. You have done this before. Okay, so if there was a similar question where we are working out the integral of two things which are multiplied together, then I can get the formula or the method or the process by integrating this here. So what I'm going to do is show you where it comes from. You don't, I think, need to prove this at any point in any exam, but this is where the rule comes from. Now, if I was to integrate everything there, okay, it would be fair because I'm integrating everything that you can see. So if I integrate the left-hand side, now this is d by dx. So this is the differentiated, if I was differentiating uv, that's what I have on this first step. So to integrate that, I just end up back with what I started with, which is uv for the left-hand side. So if you integrate this, it's the reverse process of differentiating, so you end up back with what you started with. But on the right-hand side, then, I have two terms which I need to integrate. I need to integrate u dv by dx plus integral of v du by dx. So what I end up with here is just a complicated looking expression, but if I rearrange this slightly, if I swap uv, and let's pick one of these integrals, let's pick this first one here. If I swap things around or move things about, I can rearrange it eventually to get this. The integral of u dv by dx is equal to uv minus the integral of v du by dx. So that's a slightly different variation. I suppose I just took this over to the left-hand side, and you end up with this. This is integration by parts. So for the product rule, which is where you have two things multiplied together that you differentiate in, you have uv to begin with. The difference is when you have two things multiplied together with integration, one of them is called u and the other one is called dv by dx. I should have written dx on the end there. Oops. So we can put dx on the end of each of these. So your two terms to begin with are u and dv by dx. So whatever the two things multiplied together, that's what you can call them. And if you want to integrate it, it is uv, take away the integral of v du by dx. So there's a lot of complicated letters, etc., going on with these questions. But this is the formula, and it is far, far easier than it looks. Okay, so with the examples, I'll just write, let's make the pen a little bit smaller, the integration by parts formula at the side of the page. So here's one for you to memorize, unfortunately. U dv by dx is equal to uv minus the integral of v du by dx. Okay, so this is what we have here. This is our integration by parts formula. Here is my first question. Find the integral of x sine x. So most importantly, you would spot that this is an integration by parts question because there are two things multiplied by each other, x and sine x. One of these we can call u. One of these we can call dv by dx. And it doesn't actually matter which way around they go. For this one, I'm going to do them in the order that they come. I'm going to say, and this is what we should be doing to start these questions, before you start using this formula, let's just label things. U is x, and dv by dx is sine x. Because they're the two things that we're multiplying together in this question. They're the two things under the integral symbol with integration by parts. Now, what I want you all to do, and I'm sure Mr. Stratford would be the same with his class, is when you start one of these questions, sort of create like a little box or just a little area at the start of the page where we actually write down what u is and what dv by dx is, which I've already done, but the other things that I need as well. I'm going to need v and I'm going to need du by dx. So I can get them from these first terms. I can get du by dx from u, and I can get v from dv by dx. So u, if I want to find du by dx, that's just differentiating that, which is 1. If I have dv by dx and I want to get back to v, that's integrating, because you're going back from the differentiation to the original term. So to integrate sine x in this case, you've just been doing that, and your assignments, I can't speak for Miss Stratford's class, I'm sure they were the same, but my lot were excellent with these, I gotta say. So that's going to be minus cos x when you integrate sine x. Okay, so you may be wondering, where's the plus c on the end here? There is no need for a plus c, and we'll see why later in the question. So you should always start by writing down what the 4 things are that you need to substitute into this answer over here. You're going to need u, dv by dx, v, and du by dx. Now you get the first 2, you have got the first 2 from what you have in the question, and you can get the other 2 from either differentiating or integrating. So let's actually go into this question now. So we have integral of x sine x dx is equal to uv. So u is x, v is minus cos x. So we're going to times that by minus cos x. Take away the integral of v du by dx. So v is minus cos x. Du by dx is 1 dx. Now it's just a case of simplifying, and also we have a little bit of integration to do as well. So first thing, x times minus cos x, we'll write that as minus x cos x. Take away, well, I'm integrating this. Now this, if I times it by 1, is minus cos x. And when you integrate the minus cos x, that's going to come out to be a minus sine x when you have that. So that's going to be minus sine x when you integrate that. Cos integrated would become sine. So if you have minus cos, that's going to become minus sine. Now we'll have a plus c on the end. But the reason we didn't write a plus c earlier is because it's just a constant number. There's going to be a plus c later on. So we may as well just save it till later. It's just going to be combining this one with this to create another number anyway. So there's only real need to write a plus c right at the end. So minus x cos x plus sine x plus c is the answer to that question. Does anyone have any questions about that? I know it can get quite complicated maybe in terms of all the x's and the v's and the u's and whatever, but you just need to remember there's 2 things multiplied by each other and underneath the integral symbol in the question. You need to label one as u and the other one as dv by dx. And it doesn't matter which way they go around. One you differentiate, one you integrate, sub it into the formula. Okay, example 2. I think there's 4 questions we're going to be doing today. Oh, tell you what, let's put this formula here on every page. So I'll keep that up there. Just a reminder. Okay, so this time there's a bit of an issue. It doesn't necessarily appear obvious, but don't write this. If you were to start off by saying that u is x and v is ln of x, okay, oh, not v, sorry, dv by dx, u for the first term, dv by dx for the second term, there is an issue. Anyone spot the issue? Well, at least I want you to have a think for now. There is an issue with the next step of this question. So we're going to have to find du by dx for this one. We're going to have to find v for this one before I substitute anything in. Well, the issue isn't with x, because if you differentiate that, it comes out to be 1. The issue is with this term. There's a lot of rules we have learned over the last few lessons, few weeks and months, but we don't yet know how to integrate ln of x. We know how to differentiate it, but you don't know how to integrate it. So if you chose this way around for your 2 terms at the start, problem. Because that would mean I have to integrate ln of x, which we don't know how to do. So let's just label them the other way around. It doesn't matter. There's just 2 things multiplied by each other. It doesn't matter which way around they go. That's supposed to be an x, by the way. So if you differentiate u, you have 1 over x. Integrating this, you end up with a half x squared. And now you can sub all of these things into your formula. So it's going to be the integral of x ln of x dx is equal to uv. So that's ln of x times a half x squared. Take away the integral of v du by dx. So that's a half x squared times ln of x. No, it's not. I thought there was an issue there. Apologies. It's a half x squared times 1 over x. I misread the question, du by dx. Now I would simplify this first before you go any further. I guess you can combine these 2 together actually. So it's going to be a half x squared ln of x minus the integral. Now what you have here is the x squared should be on the top of this fraction because a half x squared is the same as x squared over 2. So multiplying fractions or cancelling things out, you end up with an x squared divided by an x. So that gets rid of one of them. And you should end up with x over 2. If you're simplifying that, which is going to become a half x squared ln of x of taking away. Now the integral of this, it's the same as a half times x. So that becomes x squared divided by 4. That is what it should become exactly, plus c. Okay, you can write that as a quarter x squared or x squared over 4. It does not matter. Okay, next one. A little bit more complicated in terms of the terms that you have in this question here. It's a little bit blurry for some reason, this one, but it is 3x to the power of 5 times ln of 2x. So let's put up our parts formula again here. So it's going to be, oops, don't need to write that yet. I want to write what u is, what du by dx is, what v is, and what dv by dx is. Those 4 things. Now, just take a moment to be think now, is it possible to integrate or differentiate both of these things? Now, you don't know how to integrate ln of 2x. Therefore, you should not put that as v. Oh, sorry, I'm half asleep this afternoon. Apologies, that should have been dv by dx and v in that order. You shouldn't put ln of 2x as dv by dx because you don't know how to integrate that to get back to v. So you should put it as your u, and this one should be 3x to the power of 5. Okay, now we did a bit of differentiating this in the past, but essentially ln of 2x, when you differentiate, becomes 1 over x. ln of any value of x will just come out to be 1 over x. It would be different if the 2 was in front, but it's not. It's part of this. You could put a bracket around it there. Okay, integrating this, going to raise the power to 6, then divide by 6, and you end up with, if you simplify it, a half x to the power of 6. Okay, now we're going to sub all of them into this formula here. So it's u dv by dx. So that was 3x to the power of 5 ln of 2x dx is equal to uv. So it's ln of 2x times v, which is a half x to the power of 6. Take away the integral of v du by dx. V half x to the power of 6 times du by dx, which is 1 over x dx. Very similar to the last one in the fact that I have to simplify some of this first. There's not much you can do apart from put these two terms together at the start, though, in terms of simplifying. So that's going to become a half x to the power of 6 ln of 2x. Once you just put all of those things together, put the letters in front, I guess. Take away. Okay, so it's the integral of all of this. Now, again, this is the same as x to the power of 6 over 2. So there's an x going to cancel out on the top and the bottom, and we're working out the integral of, well, it ends up being a half x to the power of 5 dx. Half x to the 6 ln of 2x minus, now this, we're going to raise the power to 6, then we're going to divide by 6. So it actually comes out to be 1 over 12 x to the power of 6 plus c. So those 3 examples that I have done so far are pretty standard questions, I would say. There's not really much differentiation between the questions, and I mean differentiation in terms of like it being different to each other. We've had some questions. We have 2 terms multiplied by each other. You need to call one u and one dv by dx. Same for that one. Same for that one. Come up with the other 2 terms and sub it all into the formula. However, there's one question I'm going to finish on today, which is very different. It's more of like a bit of a proof than anything, but it says use integration by parts to actually find the integral of ln of x. Now, this is something I've mentioned. We don't actually know how to integrate at any point so far today, so I've actually been wary of choosing this so far. So let's actually work out how to integrate it. You can actually work out via using integration by parts. It doesn't necessarily immediately look like it because it only looks like one term there at the moment. But if I put my integration by parts formula up there, it needs to be 2 things multiplied by each other. Now, technically, this is and can be written as 2 things multiplied by each other, because I could write it like 1 times ln of x dx, where technically now there are 2 terms multiplied by each other. One of them is going to be called u, and the other one's going to be called dv by dx. So I'm going to label them in a moment. My first step, same as normal, is to write my 4 things that I need. Try and keep it in the right order, like I have done there. So again, we need to choose carefully. I should put ln of x there because I know how to differentiate it, but I wouldn't know how to integrate it yet. and I'm going to put 1 there. Okay, so differentiating this, that's 1 over x. Integrating 1 is x. Just bring the letter in. So for my integral of ln of x, or technically 1 times ln of x, it is uv. So that's x times ln of x. We could just put it in straight away like that. Take away the integral of v du by dx. So that's x times 1 over x dx. I'm just checking my workings here because I feel like I've done something wrong. V times du by dx. No, that's all okay to me. So that is x ln of x minus, and that's the integral of 1, because you end up having to do x divided by x, which cancel each other out. So it comes out to be x ln of x minus, if you integrate 1, you end up also with x. But don't forget, right at the end, don't forget that plus c. So that's not necessarily one that you need to memorize off the top of your head, but that is how you would integrate ln of x. Now you can see why I chose not to put ln of x as the one that you had to integrate earlier. Okay, so for the rest of today's lesson, all I want you to do is have a quick read through, at least the very start of Mr. Stratford's notes, up until I think he has this question in his notes after speaking to him earlier. There is a more difficult section of this stuff that I will be doing on Thursday. Okay, so well done for sort of turning up today. And that's it from me. Just have a read through today. I don't know if he's posted the actual assignment yet. Hopefully he has, but not then, don't worry. And that's it from me.